Well, I started this video once already, and then about 20 seconds into it, the dog started barking because the mail truck was here. And so I just decided to start over. So as having learned yesterday, I hope things about polynomials, like how to identify them, how to identify their degree, and you also saw how to add and subtract them. We're going to step it up a little bit and talk about multiplying them, but we'll sort of ease our way into it. So first thing we're going to do is multiply monomials together. Sounds like monorail, because mono, as you know, means one, and so a monomial is a polynomial with one term in it. And so we're going to multiply them together and see how that goes. It's just bookkeeping. Okay, so I'm gonna show you the top three, and then you can take a few seconds and work on the pick one of the bottom three and work on it. But notice there's no addition anywhere. This is all multiplication. There is a negative there, but that's not subtraction, right? There's a context here. That's just the number -3 is the multiple in that middle one. But let's just start with the first one there. So we're going to multiply 5x squared times 4x squared. At some point in early on algebra, you would have learned magic words like associative and commutative, and at the time you're like, why do I need to know these words? Well, you need to know how you were allowed to rearrange calculations, and this is a good example why. Multiplication is commutative, which means, commute means to move around. In multiplication, you were allowed to move around the order of the multiplying. Okay, which helps in a case like this, because what I can do here is, since the 5 is multiplying the x squared and that all is multiplying the 4, which is multiplying another x squared, this is all multiplication. So we can exchange places with some of these things. So I would rather see this as 5 times 4 times x squared times x squared. It's the same thing. And now I can see that that's 20 times, and then here x squared times x squared. Remember, we're going to add the exponents together, so that will be 20x to the 4th, and we're done. Okay, bookkeeping and remembering what to do with exponents. That's the other crucial thing. This is the second one that was on the screen. It involves a little bit more reorganizing, and after I would recommend doing the reorganizing explicitly to help you practice grouping things with your eyeballs, but eventually you can probably just rattle off what the result needs to be. But I'm gonna separate the -3, and I'll put parentheses around it just to remember that minus sign is attached to the 3. I'm not subtracting that term from anything other than 0. There's a times 4. There's, from the left, an x cubed, but from the right there's an x. From the left there's a y squared, from the right there's a y to the 5th. And now we just tidy up. What things are left that we can multiply together? Well, the 4 and the -3, when we multiply those together, that's a -12. X cubed times x, there's 4 x's all together, so that's an x to the 4th. And then here, 2y's times 5y's, 7y's all together, that's y to the 7th. We add the exponents, and boom, we're done. Okay, and then here, well, more clutter, but the idea is going to be exactly the same. The fact that we've changed away from x's and y's is irrelevant. Let's see, so what have we got? Let's go gather the numbers. We got a 1/2 and a 6. So I'm going to write down the 1/2 times a 6. Remember, everything is multiplied here. Let's track down the a's. Well, there's 1, there's 1. So we got an a cubed times an a squared. Now we're going to track down, it looks like there's some b's in here, so I'm going to track down the b's. There's 2 of them. There's a b from the left and a b squared from the right. And what else? Well, there's a lonely c squared in there too. All right, and now clean it up. The 1/2 times a 6 is 3. The a cubed times the a squared, that's a to the 5th altogether. We have a b cubed altogether, and then that lonely c squared is still just c squared, and that's as good as we can do, and boom, we're done. Okay, so yeah, if somebody's monitoring this, give this a pause, just take a minute or something and just pick one of these 3 at the bottom and give it a try. The brave of you will go for the last one, because if you can do the last one, you can certainly do the other 2. If you're still feeling a little iffy about it, try the first one. Just see how you do. And then click play again, and we're back. Okay, so this time we are going to do multiplying a polynomial by a monomial, which again means polynomial like 2x squared plus x plus 4. A monomial is something with one term, like that 5. So this time we do have some additions and subtractions in the mix, and so we're not necessarily able to just willy-nilly reorder everything going on, but we can still do things to our advantage. So I didn't write this down on my tablet like I did the other ones, which was dumb. Okay, so here comes the first one. We're going to do 5 times 2x squared plus x plus 4. So the monomial is the 5. The polynomial, poly is multiple, right? And so there's the rest of it. Multiplication is distributive, meaning if there's a bunch of things inside parentheses and something is multiplying that frame, the thing that's multiplying gets multiplied by everything inside there. So this 5 has to multiply the 2x squared and the x and the 4. Okay, so let's just do those multiplications and write down the results. Let's see, the 5 times the 2x squared, that will give us a 10x squared. The 5 times the x, that will give us a 5x. And the 5 times the 4 gives us the 20, and boom, we're done, because there's no more simplification to do. That's it. Let's take a look at the second one. 2x squared y times 3x minus y. Okay, it's sloppy, but I just can't write on a tablet with this digital pen without making little wiggles. But the same idea applies as before. Right? The multiplication is distributive, which means this individual term, the 2x squared y, we could write that as x squared times y times 2, or y times 2 times x squared. That reorganization can happen anyway, but there's no reason to change it. But for the multiplication of the big frame, the big picture, we have to remember that 2x squared y has to multiply both the 3x and the negative y. So we're going to watch that minus sign pretty carefully. Okay, so I'm going to take the 2x squared, and I'm going to write out what I get when I multiply it by both of those things. So, and I'm going to do this I'm not going to do too much at once. I'm just going to do my 2x squared y times 3x minus 2x squared y from the front times y. Okay, so the minus sign there has become the minus sign there. Now I realize I can clean this up a little bit. For example, in this first one, I've got a 2x squared and a 3x. Right? Well, the 2 and the 3 make us multiply to a 6. The x squared times the x. And remember, this is using the commutative property of multiplication. All of this is multiplication there. So we can rearrange that multiplication as it's convenient for us, which is pretty rare in math, right? So the x squared multiplying by this x gives us an x cubed altogether. And then there's that lonely little y sitting there. And then in the second term, what can we do? Well, there's not a whole lot we can do except put those two y's together as y squared, and boom, we're done. All right, one more from this page, I believe. Yep, so the last one we're going to look at is 4a times a squared b plus 2b squared. All right, I'm going to rattle this, see if I can rattle this off a little quicker. This 4a times the a squared b, so I'm doing this multiplication. It looks to me like the 4 has no partners, but it looks like the a is going to multiply the a squared to make a cubed, and this poor lonely b doesn't get multiplied by anything. Poor guy. And then the 4a times the 2b squared. Well, the 4 times the 2 makes an 8. The a times, oh, poor little a, he doesn't get to multiply anything for this term, and then there is still that b squared that's also not getting multiplied by anything. The only thing that got multiplied for the second term was the 4 and the 2. Everything else just kind of joined the pile. But there you go, you're done. You know, at some point you might look at one of these and say, well, maybe I can tidy that up a little bit. Ooh, look, I could factor a 4, I could factor an a, but if you do that, you're going to get right back to the to the beginning result. So even if you've done this and it seems like you might want to factor things, you would just be going backwards in the process. So there is no reason to do factoring here. All right, so again, if you are able to, give it a pause. Just pick one of the ones at the bottom, give it a try, make sure that you were on top of this. Okay, and finally, for today, multiplying binomials. By 2 binomials are polynomials with 2 terms in them. This stuff you've done before. I mean, you've done all of this before, but maybe not with all the lingo, right? Seeing that this type of multiplication is just one of many types of multiplications that can happen with polynomials. So let's just recap what this is. So using FOIL, F-O-I-L, that stands for first, outer, inner, last. If you like to memorize mnemonics like that, go for it. The other thing to remember is, just as mentioned, this multiplication that's between the first parentheses x plus 2 and the second parentheses x minus 5, that is distributive, meaning everything in the parentheses on the left has to have its turn to multiply everything that's in the parentheses on the right. So there's 2 terms on the left, 2 terms on the right. That means 4 multiplications have to happen to get this thing done. All right, so the first multiplication that has to happen, let's make sure I got a color that will stand out from the function. I'm going to do x times x. Okay, so that's going to be equal to x squared. And in the FOIL, F-O-I-L, there's the first. We've multiplied the first 2 terms. As long as we're thinking about this first x, let's also multiply it by that negative 5. So there would be a negative 5x as the result. Okay, and in the FOIL, that is the outer. We multiplied the x and the negative 5. Those are the outer bits of this structure. Yeah, switch color again. So now it's the 2's turn. The x here, the first x has done its job. It's multiplied everything over there. So let's move to the 2. The 2 has to multiply that x. That'll give us a 2x. In the FOIL, F-O-I-L, that's inner, the inner 2 bits. And then finally, last. The 2 multiplies the negative 5, that's a negative 10. So there are the 4 multiplications that happen in this product, and we recognize that, oh look, we can clean this up a little bit because the x squared doesn't match anything, the negative 10 doesn't match anything, but we can certainly squish these 2 together. Negative 5x's plus 2x's brings us up to a negative 3x. And boom, we're done. Okay, the next example was x plus 5 squared. This is a binomial being multiplied because, remember, x plus 5 squared is x plus 5 times x plus 5. Okay, rolling through this again, you can think through the FOIL, F-O-I-L, first, outer, inner, last, like in the picture above, or you can just remember distribution. Everything in the first group has to multiply everything in the second group. So if I pick up my first 2 x's, I get an x squared. If I pick up my first x with the 5 from the second group, that's going to be a 5x. And then I'm going to focus on this 5 and say, hey, he's got to multiply that x. That's going to be another 5x. And then this 5 has to multiply that 5, and that's going to be plus 25. And then just like the one above, I say, hey, look at that. I can clean this up a little bit. Those 2 terms in the middle will shake to a 10x. And boom, we're done. Okay, I think this is the last one from that page. Let's double check. Yep, 3a squared minus b times a squared minus 2b. Or not 2b. Ha ha ha. Okay, so same rule. I mean, there's no x's here, but who cares? It doesn't change the process. First, outer, inner, last, when you have binomials multiplying together. If you don't want to walk through that, just keep track of the details of the distribution. This 3a squared needs to multiply that a squared. That will give us altogether 3 times a to the 4th, right? And then this 3a squared needs to multiply that negative 2b. Now, there's a negative from the negative 2b. 3 times 2 is 6. And there's an a squared and a b. We can't do anything there except write them down each by themselves because they don't, I mean, there is a multiplication of a squared b, but they don't share a base. You can't add exponents or anything like that. They're just glued together. Then we need to gather the negative b term times that a squared term. So there is a negative, b times a squared. I'll just call it a squared b so that it matches the other one. And there's the UPS truck. So Tux is barking up a storm. And then this b again times that outer b, that's going to be, this is careful now. So got a negative times a negative. That'll make a positive. And then there's that 2, and then there's 2 b's multiplying. So there's a b squared. And, well, the 3a to the 4th doesn't combine with anything. The 2b squared we just generated doesn't combine with anything. But these two in the middle, it looks to me like there are now negative 7 a squared b's. And we're done. All right, so that's the idea with these multiplications. There's one more way to make it worse, but we'll take a break and do that tomorrow. So again, pause here, see if you can try one of these. Talk to somebody sitting next to you, see if you both get the same thing. And then there is a worksheet that goes with this, a practice sheet, so you can go dig that out from Google Classroom if it hasn't already been printed, and practice this more. The more you practice it, the better you'll get at it, and then that will make further calculations simpler. Is there a time in life when somebody's going to catch you on the street corner and force you to multiply out polynomials? Probably not, but you're learning patterns, you're learning quantitative adeptness to be able to combine quantities and see what the result is, and that pays off in a lot of ways down the line.